Okay, let's give our notes packet a little look here. You've read the 4 pages that I gave you, and those are great pages. We should have all that figured out. Hopefully, most of that is review for you. But as we look at pictures of lines, oftentimes on tests they just ask us, what do you know about this slope? Is it positive? Is it negative? Is it constant? Is it zero? Is it undefined? So looking at our pictures here, and we have lines labeled N, H, P, and V. Hopefully you're looking at line P and going, well, that's positive slope. And not only is it positive slope, if I look at what's happening, I'm going up one, right one, up one, right one, up one, right one. I think that is not only just positive, it's positive 1. Line N, on the other hand, is going downward, so it should have a negative slope. Down one, right one, down one, right one. I think it'd be fair to say that its slope is negative 1. Our horizontal line H, now that one, we have 0 vertical movement. So 0 movement, I don't care then left or right, doesn't matter how far we go. The fact we're moving 0, that means our slope is 0. And then V, our vertical line, that's the one where we have to have undefined slope, because our change in Y could be 1, 2, 3, doesn't really matter, but our change in X is 0. And hopefully you remember from Algebra 1 that you can't divide by 0. So I'm going to say my V line has undefined slope. Where does the graph cross a y-axis? That's our y-intercept. That's when X is 0, what is Y? So hopefully now we can look at these lines right here, or I should say let's go back and look at the previous lines. So we had our previous lines, our N line, we had a slope of -1, and it looks like it crosses the y-axis at 0, so its y-intercept is 0. So I'm going down here and saying, yep, y-intercept is 0. My H line, my horizontal line up here, looks like it crosses the y-axis at 3. Horizontal line, y-axis, 3. P, well, P is this line with positive slope. It also crosses the y-axis at 3. There's a point of intersection there. And my vertical line, it doesn't cross the y-axis at all. And our y-axis is over here. Our vertical line, there is no y-intercept. So then I look at these new lines right here that I haven't worked with before, and I'm trying to figure out, all right, what's my slope, what's my y-intercept? So I'm going to look at this horizontal line first. Slope for all horizontal lines is 0. There is no change in y. My y-intercept right here on the y-axis, when x is 0, y is 5. So I'm going to go slope is 0, b is 5. The positively sloped line right here. My y-intercept, 1. B equals 1. What's my slope? Well, I'm going to try and count until I run into another nice point. So my slope up 1, up 2, up 3, up 4, up 5, right 1, 2, 3. So I'm going to say my slope is 5/3. Likewise for my last line, what's my y-intercept? Well, I can see that it crosses the y-axis at 3. And now it's a negative slope, so I'm going to have to start here and go down 1, 2, 3, right 2, a slope of -3/2. Having a graph there and being able to see those corner points so we can get slopes and y-intercepts is really helpful. I had you graph on your quiz on Monday a line parallel to a given line, a line perpendicular to a given line through a point. Now we need to do a little fine-tuning here about why we have parallel and why we have perpendicular. So the slope of the line that I see right here, I see a nice corner point, up 2, right 1, up 2, right 1, up 2, right 1. That says we have a slope of 2. Change in y over change in x. What's the y-intercept? Right here it's 1. Okay? Now I'm going to go ahead and I want you to change this ordered pair from 2, 5 to 1, 3. Because now I can construct a line through this point, through this line, and it sure looks like it's going to be perpendicular. But before we do that, let's talk about its slope. I'm going up 1, left 2, up 1, left 2. So my slope, negative 1/2. I know it's a negatively sloped line because it's going downward. I have a vertical change of 1, a horizontal change of 2. All right. If I want parallel, I want the line to be parallel through this point, parallel to this line. Well, if I'm going to keep them from intersecting, I better use the same slope I did for the first line. If it has a slope of up 2 over 1, then to stay parallel, I better go up 2 over 1, up 2 over 1. Or I can reverse it and go down 2 left 1, down 2 left 1, down 2 left 1. Now I'm kind of guessing here that my y-intercept is negative 4, but I think we can talk ourselves into it kind of from a way of looking at our graph. I see this point right here on the one line, and 1, 2, 3, 4, 5. There's another point on a line that's parallel to it. Here's a point, 1, 2, 3, 4, 5. It's like these graphs are 5 units apart on the y-axis. So if I'm at 1, 1, 2, 3, 4, 5, I think I can talk myself into a y-intercept of being negative 4, because those lines have to stay 5 apart in the y dimension in order to keep them from intersecting. I'm going to flip over here, look at the next page here, and kind of give you a little brief why we have to be careful with parallel lines. All three of those look parallel, but they aren't. Okay? If I look very, very carefully, and this is really hard to do, trying to find these corner points. 1, 2, 3, up 3, over 2, slope of 3/2. You have to really, really look carefully, and that's hard to do sometimes. So likewise here, I have to find a good corner point, and then it looks like up 1, 2, 3, 4, 5, right 1, 2, 3, slope of 5/3. Lastly, I'm going to look at this line. I'm going to try and do the same thing. I'm going to try and find a good corner point. Then 1, 2, 3, 4, 5, 1, 2, 3, also a slope of 5/3. Therefore, my two lines that are parallel are the two lines that have the same slope of 5/3. In this case, my lines that I labeled B and C. Okay, perpendicular postulate, we talked about that, had it on our quiz. Through a point, not on a line, there can only be one line drawn perpendicular to the given line. So looking first off at the line that's already drawn for you, what is the slope? Up 2 over 1. I can see it, up 2 over 1. What's the y-intercept? Where does it cross the y-axis? Right there at 3. So if I want something parallel to that line, I would have to use a slope of 2. And to be perpendicular, if you recall from our notes, we talked about perpendiculars had to be opposite reciprocal slopes. So if I go opposite reciprocal of 2, that's negative 1/2. So up 1, left 2, up 1, left 2, up 1, left 2. That should be my perpendicular line. And hopefully we can see that the lines are intersecting at the point 2, 7. And I guess I just asked again, remember that my slope is negative 1/2. And reminding you, some of you maybe didn't catch in the earlier chapter, this is our symbol for perpendicular. Perpendicular lines have, that should say have, opposite reciprocal slopes. So can we keep moving with this? Hopefully, yes, we can. This reminds me of what we had in the notes that I gave you the other day, that I asked you to read on Monday. Here is a point, negative 2, 0. I plotted the point, negative 2, 0. This is a line, y equals negative 1/2 x plus 6. If I have a y-intercept of 6, right there, 6. Slope of down 1, right 2, 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 or up 1, left 2, up 1, left 2, up 1, left 2. I can get a really good line there. So the slope of the line that we have given here, negative 1/2. So remember, slope is change in y over change in x. So as my x's are going over 2, my y's are going down 1. My x's are going over 2, my y's are down 1. X's over 2, y's are down 1. If I want to get a parallel line through point P, through that point negative 2, 0, there's only going to be one line parallel to it. What's going to be the slope of the parallel line? Same as the slope of the original line, negative 1/2. What's going to be the equation of it? Well, I choose point slope form. Y minus y1 equals slope times x minus x1. And now if we want, we can even graph that line. Y-intercept of negative 1. And we have a slope of down 1, right 2, down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2, up 1, left 2. Hopefully you can see that this line will be parallel to the first line. I can even put my little parallel symbols on there, my little triangles on there. Those lines are parallel. For the perpendicular, again, just one line perpendicular to the given line. And the slope of it, well, it has to be the opposite reciprocal. So the opposite reciprocal of negative 1/2 is positive 2. So as my x changes by 1, because positive 2 is really the same as 2, 1, change in y2, change in x1. So as my x's change by 1, my y's increase by 2. What's the equation of my line? Well, I can see a y-intercept of 4. I have a slope of 2, so y equals 2x plus 4. And now I can answer the question, what do I have going here? I have a y-intercept of 4, a slope of 2, and if x is 0, when x is 0, y is 4. That's my y-intercept. Have to know the y. I want to know the y-intercept. I want to know the slope. Then I can have the equation of a line. So how can we get that? Just a gentle reminder here, our last chapter test, this went really well. If we get an equation of a line and it's not in y equals form, using our properties of equality, I can add 2y to both sides of the equation. I can subtract 5 from both sides of the equation. I can divide both sides of the equation by 3. And then I can simplify what I have there. And then the symmetric property says I can just flip it over and have the y equals on the left. And now I can look at that equation and say the slope is 1/3 and the y-intercept is negative 5/3. There's lots of applications for these. We saw that arithmetic sequence, that common difference. We're talking about every time we have a slope, my y changes by 1, my x changes by 3. We can write that equation and talk about how those things change and work with anything we want. Okay, so one good example here, I want to show you an example of how we sometimes use slope and intercept, and that is we talk about business, we talk about making money, we talk about what happens. So I'm going to talk about in 2000 a business made, we have a little typo there, made a profit of $8,500, and in 2016 the business made a profit of $15,400. So I'd like to be able to think about how that is a graph and how we can show the business making money. So I don't want to have my x-axis be way out there at 2000. So I'm going to say, let's let 0 right now, let's let 0 represent 2000. So I'm going to say 0, 8,500. Okay, in the year 2000, which represented by 0, 8,500 is my profit. So now in 2016, oh shoot, I have completely made an error here, haven't I? That should be 15,400. So this should be 16 minus 0, and that should be 16. And now I'm going to have to look at my calculator and go, oops, what is 6,900? Can I divide that by 16? And what do I get? I get not this, but I get $431.25. So every year the profit is growing by $431.25. Well, I'm glad I caught that error right now before all of you copied that down. But in 16 years we had made $6,900. $900. And so if we divide that and make it per year, every year we expect our profit to grow by $431.25. So every year we're making $431.25 more than we were the previous year. Okay? And then lastly, some of you were doing this on your packet already, and some of you may get to this today as you work on your stages, your different stages of lines. We have to be able to graph lines. And I think that's where you probably have appreciated your y equals mx plus b the most, because if I have the y-intercept and I have the slope, I should be able to graph the line. So a y-intercept of 2, a slope of 3. I come to my y-intercept of 2. I go up 3 over 1, up 3 over 1. Because I want my line to look nice, I'll reverse that, go down 3, left 1, down 3, left 1, and I can graph line A pretty efficiently. I can also take a look at line B and go, wait, it's not in slope-intercept form, so I can subtract x from both sides of the equation. We can divide both sides of the equation by 3 and get a y-intercept of 2, but now a slope of negative 1/3. Down 1, right 3, down 1, right 3, and hopefully some of you are going up 1, left 3, and hopefully you're going, wait, those lines are going to be perpendicular because those lines have opposite reciprocal slope. And then our last line, this is in point slope form. I'd like to say my slope is 3, and the point that I can start at, I don't need to put this in y equals form. My point would be negative 1, 2, because remember it's always y minus the y value of the point equals slope times x minus the x value. So if I get to negative 1, 2, and I very carefully do a slope of 3, I can see that lines A and C are parallel. They have the same slope, different y-intercepts. They're pretty darn close together, so you have to be careful. And not only that, but if A and C are parallel because they have the same slope, and B has the opposite reciprocal slope, then not only is line B perpendicular to line A, line B is perpendicular to line C, and it looks like, if I look at this graph very, very carefully, it looks like lines A and B are intersecting each other at the point 0, 2. And it looks like B and C are intersecting each other over here somewhere, and that point's not looking very comfortable right now. So I'm just going to hold off for a second and go, I think we can figure that out and leave that for a conversation on Thursday.